Hello and welcome to this video on resolving vectors. So we're often only giving the resultant vector value, and sometimes this isn't useful. We might need to resolve it into its horizontal and vertical components. So this is called resolving a vector, and this example will show you how you can do that. So in this example, we've got a 20 Newton force on a slope of 30 degrees. Now we want to resolve it into its vertical and horizontal components. So to do this, I'm just going to label the sides of this triangle. So if we've got the 30-degree angle, the side opposite that is the opposite. The 20 Newton is the hypotenuse, and then this is the adjacent. So now that we've labelled the sides, this being fx, as in the horizontal component, and this being fy, the vertical component, we can use trig and we can find out fx and fy. So we have the hypotenuse and we have the angle. If we look at SOHCAHTOA, the vertical component is the adjacent. So what do we have that's got the hypotenuse, the adjacent? We have cos. So for the fx, cos theta is the adjacent, which is fx, over the hypotenuse. And if we rearrange this for fx, this gives us fx is h cos theta. So when we plug in the numbers, fx is 20 newtons times cos 30. And remember to make sure that your calculator is in degrees. This gives us 17.3 newtons. And we can do exactly the same for the y. So fy, we have the opposite, which is fy. We've got the hypotenuse and we've got the angle. So in SOHCAHTOA, what do we have that has the hypotenuse, the opposite, and the angle? We've got sine. So exactly the same for fx is fy. Sine theta is fy over the hypotenuse. Rearrange this for fy. This gives us h sine theta, which is 20 newtons times sine 30. So fy will be 10 newtons. So there you go, you've resolved the vector.